Hi guys, welcome to another video. In this one I'm going to take you through a little bit about how we find files on our computer when we want to use them in our applications, and also about how we read text files. Now when it comes to reading text files, there is many ways you can do it in almost every programming language, and .NET's no exception to that rule. We can make it as easy or as complicated as we like. There's probably 3, 4, 5 ways I could think of doing it just off the top of my head. And also when you're reading text files, you might be reading a file, for example, that has text that's comma delimited, which is a common output from spreadsheets and databases. Or you might be reading a file that's in an XML format, which is very popular as well for a lot of enterprise applications. But for today's demonstration, we're going to keep it nice and simple, and we're just going to have a plain ASCII text file, the sort of text file that can be created by something as simple as Notepad, for example, in Windows. So, without any further ado, let's have a look at how we might work with that. And we're going to do 2 scenarios. We're going to work with a scenario where we create the text file inside Visual Studio, and then we go ahead and read it. And then we're going to look at a scenario where we actually want to load a text file that's located somewhere on our hard drive, maybe created by another program or maybe created by the user. So let's start with the first scenario where we're going to do it all inside Visual Studio. So I'm going to create a new project using WPF, which is what we use for all our demos. And I'm just going to call this one reading text files. Since this demo is going to concentrate on the code, the UI is going to be very simple. All I'm going to do is just add a button. So it comes back to us. There we go. So we'll pop a button on here, and what do we call it? There we go. Let's call it read file. Okay. I'm feeling like I should do the right thing here, so I'll set the horizontal and vertical alignment to center, and I'll get rid of the margin as well. And I'll put our button right dead center in the window. Okay, so we'll double click on it now. We've named it, and we'll take us to the code view. Here we are. Now we're going to start off with just creating a text file and then checking to see whether our application can actually see the file. So I'm going to go over to the project here in the Solution Explorer. I'm going to right click on the project name, and I'm going to say add new item. That's going to bring up our list of new items, and one of the items that you can add is a text file. So to save a bit of time, up here in the search box I'm just going to type text, and anything with text referenced in it will appear. And I'm just going to select text file for C#, and I'm going to name the file names.txt and click add. Okay, that's just created a blank text file, which it's opened for us automatically, and it's put the cursor in there so I can go straight ahead and start editing the file. So all I'm going to do is add 3 names into the text file. That's all I want to add to it, so I'll just close that window and save the changes. There we go. And currently the text file is sitting in our project as what's called a resource. So I can see that if I click once on it and look at its properties and see its build action is set as resource. Resources are really handy in .NET and in Visual Studio. Essentially it allows us to take various types of things, most commonly things like images and various types of multimedia, and actually add them to a resource file that's compiled and actually it makes up part of your final output of your project. In this particular scenario, I don't want that. I'd actually like this text file to be basically standalone. I do want it to deploy with the application, so when the user installs the application or runs it, it will find the text file in the right location. But I don't want it to necessarily be part of the project. I'd like someone to be able to, for example, open this text file up in Notepad and make changes to it and save it and put it back in its place and have the program be perfectly happy with that. So what I'm going to do is change its build action from resource to content. also need to make sure that the file is actually copied out when we are running the program, say for example in the debugger, or when we're running the application in its release form. Now what I mean by that is that when you actually run the program as it stands now, I'll just bring up a folder here for you. So on my particular computer I've got here, I've configured my projects to run on the D drive in a folder called Visual Studio Projects. If you haven't changed your computer settings on your machine, you'll probably find that yours is sitting on the C drive. From memory, I think they're in Documents. So mine here anyway, I've been set up for the D drive. So if I go in here and have a look and find the project that we just started on, which is reading text files, there's the actual project. It creates a folder called bin for binary, and inside that there's the debug folder, and there's actually where the executable will be when I press F5. So when I press F5 and compile the application, the executable file will be placed into this location. By setting my text file to content, and then by also setting the copy to output directory here to copy if newer, what's going to happen is that text file will also be added there. So the application then will be able to know that the text file it's looking for is in the same location as the actual executable. Now that doesn't matter if it's on the D drive like it is in my machine, or it's on the C drive on yours, or it's on the E drive, or wherever it might be. It's going to go looking for that text file by default, where the executable is, as you'll see in a few moments. Okay, let's go back to our project here for a moment. I'll just close that window so it's not distracting me. Okay, and what I want to do now is I want to check to see if that file's there. So I'm just going to run the program first of all. It's not going to look terribly exciting, it's just going to be the main window with a button at the moment. But what that should have done, again when we bring across that folder and have a look and refresh it, we'll see, there's my projects, reading text files, bin, debug. We can see there are a few extra files been added. There's a debugging file here that's been added. It's a debug database. There's also an application file, that's the actual executable. And of course, here's our text file. And I can open it up and show it to you, and it's opening up just here in Notepad, which is what I've got as the file association for text files on my computer. And it's just a normal text file, nothing special about it at all, which is great. All right. Now, there's some scenarios when you go to run your program in the real world where you'd expect that name file to be there, and it's not. It could be that the user's renamed it, or they've deleted it, or something's corrupted it. And whatever the case may be, you can't access that file. Now, if you write your code just assuming that file's going to be there, and it doesn't find it, then what's going to happen is your program's going to crash. So we need to do a little bit of a sort of precautionary step and actually check to see that the file actually exists before we go ahead and do anything else with it. So what I'm going to show you now is how we can check to see if files exist. I'm going to do an if statement, press tab twice, and in the condition there, I'm going to use file dot, and as soon as I did that, of course, the file didn't show up the way I wanted. The reason why is because this is actually part of a library called, or a namespace called system.io. So I need to add that namespace up here with the using statements. Or I can use that shortcut we've used before where you just hover over it, bring up the blue highlight there and say add using system.io. As soon as I do that, it'll turn light blue, which tells me it recognizes it. Now I'll try it again. So if file.exists, and this method has really one purpose in life, which is simply to check a path that you give it, and it will come back and say whether it could find it or it couldn't find it. That's why I've made it part of my if statement, because it comes back with true or false. Now, the file I'm looking for is names.txt. One of the handy features is if the file you want is actually in the same location as the application that is running, it's very simple to actually go and look for it. You just simply have to give it the name. And again, because the name is actually a string, I need to make sure I've got that in quotes. And what that's going to do, essentially, is if it does find the file, it's then going to go inside the if statement and you can put the rest of your code. So let's just, as a temporary measure, let's just put a message box in there and let's just say file found. Okay. So once again, we've got our names.txt file. We've set it up as content, and we said that it's to be copied if it's newer. That just means if there's any changes made here, it'll update the file for us. And in my button click event, I'm using the file exists just to check if that file is there. Let's see how we go. I'll press F5. Starts my application. Click the button, and it said it found the file for no problem at all, which is excellent. So now that I know the file is actually there and I can see it, I can go ahead and do something with it. This is the part where we come to where we're actually going to read the text file. Now, as I said, there's many ways you can do this in .NET. What I want to do with this demo is I'd like to open the file, read the names in the file, and put those in the computer's memory so I can use them later on in the application. And then close the file because I'm not going to need it after I've got those names read in and they're in the computer's memory. So there is a very easy way to do this in .NET. In fact, when I first discovered this, I was quite put out by it actually, because I didn't know it existed for a few years, and it drove me nuts having to write code the other way. So when I found out about this, it just made things so much simpler, and I think you're going to find it really, really easy to use. I need to open the file, as you said, put them in memory. So I have to have some object or some way to keep this list or collection of names. I'm going to use an array. Now, if you don't know what an array is, or you've forgotten about what arrays are, I have got another video on those, so you might want to go back and review that, and then come back to this one after you've seen it. But basically, arrays are a bit like a variable, except that they can store more than one item or object, or whatever you want to call it. So I'm going to create a string array, because these are text files. It's a text file with names in it. And the way I identify to the computer that it is in fact an array is by putting two square brackets, left and right square bracket. Then after that, I put the name of the array. So I'm going to call mine names. Now, if you've seen previous video on the arrays, you would know that I actually typed a bit more than that when I've used them before, because I actually initialized them by setting up how large they were going to be, and then populating them with a bit of code to actually fill them in with some data. Because I'm reading this information from a text file, I can't be sure at the moment how many names I'm going to discover. There might be 3, as what we've done here. There could be 20. So I'm not going to set that array to a specific size right now. I'm going to work that out when it comes time to reading the text file itself. Okay, so let's go down here. I'll just take out that message box that we had there as a temporary measure. And now what I'm going to do is read the names in from the file. So the first thing I'm going to do is say that we want to put them into the array called names. So names equals, and then file dot read all lines. And what read all lines is going to do is it's going to do what it literally says. It's going to read every line of the text file, and as it reads each line, it's going to pass it back to our array. So effectively, if you remind ourselves what was in the names text file here, Peter is going to be put into position 0 in the array, Mary into position 1, and Bob into position 2. Okay, it wants a path. So again, very conveniently, if the file I'm looking for is in the exact same location of the application, I'm just going to give it the name of the file, just like I've done there. Okay, that's it. That's all you need to do to read that file. Open it, read it, take the names out and close it. Couldn't be any easier, to be honest. Now, how do we know that the actual names have gone into our array? Well, there's a couple of things we can do. We could code a solution to show you that, and I'm going to do that in a sec. The other thing we could do is use our debugger and see what happens when we look at the names array in the debugger. So let's start off by actually using the debugger. So I'm going to put a debugger there on the line. Press F5. Okay, there's our UI. I'll click on the button. The program's executed and is now sitting on the line where it reads the text file into the array. If I hover over the array at present, it'll say null. That's saying that presently it hasn't been populated with anything. That's not going to happen until we go to the next line of the code. So I'm going to press F10 to do that now. So now we're going to press that F10, which I've just done, or you can use the shortcut up here in the taskbar, menu bar I should say. You can tell I'm doing this after dinner, a bit tired. Okay, so I've moved down the line, and let's have a look at the array. If I hover over it now, you can see now it says names, and it's got it there, string 3. And I actually can open up the array, and when I do that, I can see position 0 is Peter, 1 is Mary, and 2 is Bob. So I know it successfully read the file, no trouble at all, which is great. Okay, how could I go through and read those names in code rather than just doing it through the debugger? Let's have a look at how I do that. I'll turn the debugger off there. And what we can do is something that we've used a few times now in class as well, and there's another video again that covers this, which is the for loop. So I'm going to type for, press tab twice, and what I want to read is the names array. So the bit I need to change here is the length. I'm going to select that. Now, if I know the array is got 3 names in it, then obviously I could just put 3. That's going to loop it 3 times, and we read 3 names, we're sweet. The problem with that scenario, of course, is if someone deletes a name or adds a couple of names to the list, then we're still going to read 3 regardless of what's actually in the file. Or if we've got 2, we're going to try and read 3, which is going to create problems. So what we really want this loop to do is to be smart enough to realize how big the array is and to loop the number of times it needs to cover all the positions that are in the array. And again, .NET lets us do that. If I put the name of the array, which is names, and then put dot, I can just simply say length. And that'll come back and tell the loop exactly how many items are in that array. Okay. To see them, let's do a message box so that we can actually see them on our GUI. So I'm just going to type in messagebox.show, which you've all done quite a few times by now. And I'm going to put in the name of the array. And for the position, where you'd normally type, 1, 2, 3, or what have you, I'm just going to put I. Because if you recall, I is what's being used by our loop. That's what's incrementing every time we loop around, starting at 0 and becoming 1 and 2 and so on. So that's going to take whatever's in that current position and display it in a message box. Because what's in the array is a string, we don't have to do any toString stuff for conversions. It's already a string, so message box is fine with showing it. Okay, that looks pretty good, so let's give that a whirl. I'll press F5. There's our read file button, click on that. Peter, Mary, and Bob. And of course it finishes straight after the last one because the loop knows about the size of the array. So that's working really well. Okay. So that's a really common scenario. Let's look at a couple of variations of this just to make you aware of them if you ever need to do these things. Let's say, for example, we don't want our text file in just willy-nilly next to the executable. We'd actually like to put it into a folder so it's a bit more organized. I can do that in my project. I can go up to my project here in the Solution Explorer and I can add a new folder. And let's call that new folder data. So we want to keep all our text files, our data text files in one location. And I'm just going to click and drag my names.txt file into the data folder. It's pretty straightforward. Of course, now I've done that, I've changed the location of the file. My code's not going to work. What's going to happen is the file.exist is not going to be successful because it's going to be looking for names.txt in the root level of my project, and now, of course, it's in a folder called data. I can check that by just running the application again. And this time, when I click on the read file button, nothing happens because it goes to try and find the file. It's not successful at doing that, so none of the code inside the if statement actually gets run. Alright, so we need to modify the path to our file so that it's looking in data. And again, because this is actually on the same path as the actual application, it's very easy to do. All I've got to do here is put data \names, and that'll fix it, like so. Okay, so we'll try that again. And yep, sure enough, it's now found the file in the data folder and it can read the names. That works great, and in many scenarios that'll be perfectly fine. There is one thing I would probably change, just because it's a maintenance issue if you don't. Normally when you're writing code, if you start repeating yourself over and over again, you want to look at ways to try and reduce that repetition. It's normally what we call refactoring your code. And this path we've got going to our file is a classic example of this. I'm typing in the path twice. Now if I muck it up somehow, for example, if I check for the file called names.txt and then I make a typo and I'm only checking, after I've done that, I actually try and load name.txt, what's going to happen is my program's going to be very unhappy. So we'll try it. And basically it crashes because it passed the first test, it found the file, but when it went to read the file, I'd made a typo and it couldn't find it. So what I would tend to do in that situation is I would set up a string within this particular method, or this click event, maybe called, where is it? File path, and I would set that to the actual location. So I'll just copy and paste that, like so. And then wherever I have the actual reference to the file path, I would just simply replace it with that string variable file path. The beauty of this approach, of course, is that I now know that it's going to be applied consistently. Any changes I make there on that particular local variable is going to be used, and in both checking for the file existing and also in checking that the file is actually loaded. It just helps make the maintenance a bit easier, stops silly mistakes from creeping into your code, which can happen sometimes if you're doing a lot of alterations to your code, you're getting a bit tired and you're editing away and you accidentally change something you shouldn't have. This just makes things a little bit easier. Okay, so that's all well and good if the file you want to load is in the same location as the application you're deploying, basically. Of course, in the real world, that's often not the case. You might have a text file sitting somewhere completely different to the application. Maybe it's in My Documents, maybe it's an application file, so it's sitting in the application data folder on C drive. Maybe it's sitting on a shared network drive somewhere. Wherever it might be, you still want to be able to access it and you still would like to be able to use it, just like we've done with this one here. So let's have a look at how we might go ahead and do that. So what I'll do first of all is I'm just going to do a little bit of file management here, obviously. I'm going to go into my Documents folder on my computer and I'm going to set up a new folder called Data, and I'm going to create a text file there as well. Now I'm creating a new text file because I want to make sure that this actually is reading this particular text file and not the original. And the reason I'll know is because I'll put different names in it. Okay, so we've got Lynn, Sue and Robert. I'll save that. Now notice this time I created this text file completely out of the application. I haven't gone and added a file to the project or anything like that. So this is very much a text file that's just been created in Notepad, like you'd expect to find when people are just working on their computers and just trying to create plain text files. So now I need to point at my application to an entirely different location. It's no longer wants to go to data names.txt. We want to go to My Documents essentially and do it. There's a number of ways you can do it. I've shown people in the past perhaps a slightly longer way of doing it, which is where I've just simply gone My Documents, clicked up in here, which gives me a bit of a path name, and then I've started copying and pasting that in. It kind of works, but actually in .NET there is a really cool feature that will do it for us, and now is probably a good time as any to introduce that to you. So let's go ahead and modify our program so it can read that text file from the new location. I'll take out the actual reference to data and names.txt that we were originally using, and we'll go ahead and create a new one. So the first thing I'm going to do is I'm going to create another temporary variable, if you like, called app data folder. And I'm going to say that's equal to something. Now, .NET can actually come back with a list of default locations on your computer, and it's quite smart about it. It knows about roaming profiles, for example. It knows about locations of special folders, like where your pictures happen to be, like my pictures and my documents and stuff like that. It's aware of all those things, and they're called special folders, and that's actually how we use it. So let's have a look at how that works. I'm going to type path dot. Oh, actually, no. Before I do that, I'm just going to show you what the special folders look like first. So it's environment dot special folder dot, and when I do that, IntelliSense pops up with a whole list. So, for example, if you're looking for an MP3 file, it's not specific to your account. It's been put in a public folder. Then you'd probably look for common music. If I'm looking for some application data, to say this was an actual full-on commercial application or enterprise application we're developing, we might, as part of the installation, create its own data folder specifically for it in the application data folder on C drive. There's the way to get to it there. You can get to the desktop files from here as well if you want to. So you can see there's quite a few folders, beg your pardon, that are already set up for us that we can access. There's a shortcut to go to program files, x86 and so on, which is pretty cool. And that also means if someone's gone to the trouble of configuring their particular machine and actually relocating some of those special folders, say to the D drive, to free up space on the C drive, your application isn't going to mind in the least. It's still going to work just fine. Whereas if we hard-coded it and assumed it was on the C drive, then we can have all sorts of problems when they try and run the program because it's just not going to find the files it wants. Okay, so the one I'm going to use out of that list for this particular demo is my documents. And let's just make it to string for the moment. Okay. I'll just comment the second line for a sec. And in fact, what I might do is just comment all that code because I don't want that running. It's a quick demo I'm doing here. So I'll just comment that for a minute. So what I've done here is I've set up a variable called app data folder, expects a string, and what it's going to get is the path to my documents. Let's do a message box and just see what that looks like. So I'll press F5, read file, and it comes back with personal. So that's actually the path. I know it seems strange, but it actually is. But don't take my word for it, we're actually going to use it. So here's how we're going to do it. I'm going to tell it that I'd like to have basically the longer version of that, the path that we're used to seeing where it starts with C drive and does all that kind of thing. And what I'm going to do is I'm going to go environment dot get folder path. So, and then I'll put that special bit inside. And because I'm going to put it inside, I don't need that string bit on. Right. Let's run it again. And what this environment get folder path is going to do for us is translate that rather interesting name of personal and actually put it into a path that we recognize as being the right spot. So C drive uses Daniel documents in my case. Notice it's recognized who's actually the logged in user. So it's actually giving me the logged in user's path, which is fantastic. So if you want to have a program that has separate text files for every user that uses that machine with their own profiles, this is the way you can do it. Okay. Well, that's good, but of course, I have to go a bit further now because I don't want to just look in my documents. Remember, I created a folder in my documents called data, and I put the text file in there. So we've got a little bit more work to do. Let's go to the next line where we set up the file path. And I'm going to use another new feature that we haven't looked at before, which is called path.combine. This particular step, there's more than one way to do it, and you probably already figured this out just by using strings and concatenating strings if you can know any better. Path.combine is just a nice tidy way of doing it though. And it's path.combine. And when I do that, IntelliSense basically wants me to add the various parts of the path, and it's going to combine them for me. So the first part is going to be the path to my documents, which, if you recall, we set up as app data folder. So I'll put that straight in there. That gets the C drive, uses my documents. Then the next bit, of course, is the bit that I've added, which is the folder called data and the name of the text file. So I'm going to put a quotes in there because it's a string, and I'm going to say the name of the folder, which was data, and the name of the file, which was names.txt. And I need to put 2 backslashes in there because we're doing a path. The alternative, by the way, to doing 2 backslashes, if you didn't really like that, was to put an ampersand on the front like that, and that would work as well. But since I've been using 2 backslashes like that, I'll keep with it. Now, my computer's got a little bit of ambiguity here on combine, which is to do with my particular machine. So I actually have to declare the entire namespace there. So system IO, there we go. I don't think that'll be a problem for you if you're just using a standard Visual Studio that's got no additional add-ons added to it. Anyway, if it does, just put the system.io on the front and we'll fix it for you. So there we go, we've set the file path. Let's have a look at what the file path looks like. So I'm going to use our message box here and just tell it to show me the file path. Run the program. And there we go. So it says the file should be in C drive, users, Daniel, documents, data, names.txt, which sounds pretty good to me. That's where I put it. So now we've got the correct path. Remember the steps we did there. First step was to get the My Documents path in that line there, and then in the second line, we actually, which is the second variable, we actually give the data folder and file name. Okay, righto. So now we've done that, we're ready to uncomment our code here, because this code is going to remain the same. All that we've been doing here is just setting a special folder and a special path to it. So let's try it now and see if we get the new names. Lynn, Sue, and Robert. So, yep, that's the 3 names that I put in the My Documents folder. The great thing about the code we've just written, by the way, is just a reminder, is that we can now edit that text file. So I've got my Documents folder open here, data names, bring it up in add 2 more names to the list, save my changes, come back here, run the application again. And the program has no problem at all. Remember, the array is being resized automatically to length, so the loop knows how many times to loop around. It's setting up the array large enough, just large enough to take all the names, and then away we go. So this is a great way of doing things when you want to have, say, custom settings you'd like to read in, or you want to give the user the ability to put information into the computer in a nice, simple way. You don't want to have to go through a database and set up tables and write records and stuff like that. You just want to be able to load something as easy as Notepad up and type some stuff in, and it just works. It's a really great way of doing those simple little projects like that. Hope you found it useful, and I encourage you to have a go at it. Do try some of the other special folders as well, just so that you get a feel for how they work. It's really good also to try, for example, the app data special folders. You can see how that works with roaming profiles and things, which is kind of cool. And we'll see you on the next video. Thanks.